I think as companies, small and large, want to try a machine learning model, their fallacy is that the data is just laying there. So they say, I want to use my data. So I'm going to go in there and create insights. You actually have to know, not to try to get too technical, but you have to actually know what you want to predict. And then you have to go back and see if you have the data to predict that. And a lot of times you don't. So you might have treasure troves of data, but then when you come to actually design what it is that you want to predict, you're missing something. And so you have to actually go back and retool your software to save that piece of information so that it can become a feature in your predictions. The idea that you have all the data to make all the predictions you need and it's just lying there waiting for you, I find a little bit funny. So I think that's one of the biggest fallacies.
Oh, that's fascinating. I think that ties back into what you said before about the shift from people writing academic papers to shipping systems. So, what would you say as a trend in MLOps? Because one thing that ties into what you just said is some people are talking about a shift from the model first as the data first.
Yeah, I think that pendulum is going to swing back and forth. I think people wanted to start making models, then they realized we don't have the right data or we have to clean the data. So it was data prep, data cleaning, data warehousing. And then on the other side, it's deploying models, it's seeing whether it's model management, whether the models are drifting. There's a whole science around once you've deployed a model, how do you know it's still working? Especially if there's like some online learning component going, then your model could start misbehaving. So we've seen a number of those examples in the real world as well. I think the pendulum swings from people talking about data to talking about models to talking about monitoring. And, obviously they're all important, but you can't make a model usually without good data. So I think all of them are good for a study.
Because it seems like, at least in industry, I've seen a lot more returns from tweaking the data than actually tweaking the code and the algorithm, where like 99% of research papers are still about algorithms more than like principled ways to go about tweaking data.
Yeah, I've seen that as well. I always say any optimization method kind of takes the data and imagine you're not even making a complicated model. You're just going to use an optimizer. You have your objective function. Once you have the data, an optimizer, a learner, or whatever kind of comes up with a solution. And pretend it's an 80% solution. You can work really, really hard to make it a 90% solution or a 95. But actually, by going back to the data, adding more signals, usually that's an easier way to get between 80 and 95 rather than just kind of grinding on the algorithm.